Assalamualaikum and hello everyone. I hope you guys in a good condition. Today we are from group 3. We'll present about microfiltration and
like a bird on a tree.
Cheesemaking industry. First of all, we go for the introduction. What is microfiltration and ultrafiltration membrane? These membranes are flexible filtration methods which remove a variety of particles, pathogens and microorganisms. What does microfiltration remove? The pore size of this membrane range from 0.1 to 10 micrometer. Microfiltration allows water, ion, dissolved organic materials, small colloids, and viruses to pass through while retaining larger contaminants such as algae and bacteria. What does ultrafiltration remove? The pore size of this membrane is range from 0.1 to 0.001 micrometer. Ultrafiltration remove more comprehensive range of contaminant than microfiltration while leaving behind ions and organic compounds with low molecular weight. This membrane is used to remove very fine particles.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAZMI bin Muhammad HARUN. Today I want to present about microfiltration. So microfiltration, the pore size is range from 0.1 to 10 micrometer. So only part of viral contamination is caught up. The principle of microfiltration is as figure in 1, the membrane separating a feed solution from a permeate or filtrate has a symmetric or asymmetric porous structure. So in general, microfiltration with its larger pore size membrane allows water, monovalent and multivalent ions and virus through its barrier while blocking certain bacteria and suspended solid. Microfiltration can be useful in refining petroleum, treating water for potability, treating wastewater, and in processing dairy product while allowing protein through. So as we cover in our presentation is about dairy product in cheese making. Okay, about ultrafiltration. So the pore size is from range 0.001 to 0.1 micrometer. So it for complete removal of virus. The driving force is pressure gradient and mass transport. It's dominated by the convective flux through pores. So ultrafiltration, in contrast, with its smaller pore size, blocks everything. Microfiltration can, in addition to virus, silica, protein, plastic, endotoxin, and smoke, and also fumes. It's required slightly higher pressure than microfiltration. So ultrafiltration can be useful in treating wastewater, separating oil or water emulsion, concentrating proteins, and also in making cheese industry. So how about in membrane in industry? So filtration in the food and beverage industry is a critical part of the process. Steam wound filter and other industrial filter play an important part. Filtration keep food fresher, longer a snack shelf life, keep beverage from spoiling too soon, and help our veggies to taste and smell more palatable. Filtration plays a critical role in maintaining food processing equipment, including protection of reverse osmosis membrane used in preparation of potable water or concentration of level. So in the figure 2, it's about schematic of cross-flow membrane separation unit with key parameter. So how we understand about cross-flow filtration? So understand is cross-flow filtration is a filtration process in which feed water flow tangentially across a membrane surface. Is widely utilized in wastewater filtration. The turbulence created across the membrane surface provide optimal flux performance and prolong filter functionally. Cross filtration works by introducing feed water under pressure across the membrane surface instead of directly onto the filter. During filtration, any material smaller than the cross-flow membrane passes through the membrane, while larger suspended particulate remain in the retented stream. So, how we can relate it for cross-flow filtration with microfiltration? So, microfiltration is a separation process utilized to remove particles typically in the 0.1 to 10 micrometer range. Cross-flow separation process can be utilized to achieve microfiltration and can be ideal solution for processing in many industrial wastewater applications. Not only does cross-flow result in higher quality and larger volume of payment, but cross-flow can be used together with reverse osmosis system to build energy efficient zero liquid discharge system.
Application of membrane in food industry. Why we have to use membrane technology in industry? First, removal of microorganisms from food, purification or concentration of water, concentration or separation purification of protein, and last but not least, purification of oil. We go for application of ultrafiltration in cheesemaking. The first thing is protein standardized milk. They usually collect milk based on multiple factors such as weather, feeding, breed of lactating cows, and also stage of lactation. Cheesemaker will do adjustment of processing parameters because of the variation in the composition of the incoming milk. Usually, in many cheese plants, they're using highly mechanized equipment. 3.7% till 4.5% will be increased in the content of cheese milk. Second, medium or intermediate concentrated retentates. Medium concentrated retentates from numerous cheese varieties. Mostly the ranging is from soft to hard. Moreover, special design equipment will form cheese that able to cut and handle the firm gel resulting from the coagulation of 2,1 to 5,1 concentrated retentates. This will difiltrate with pure, salted and acidified water. Third, liquid pre-cheese (LPC) concept. Ultrafiltration will concentrate cheese milk to the composition of the drain curd being made before addition of rennet. There is no need cheese bed when there is very little way drainage. Milk was pre-concentrated prior to starter and rennet addition. Milk was ultrafiltered or when milk was concentrated is higher degree than necessary and subsequently diluted with water.
So, okay, I want to explain about application of microfiltration in cheese making. So, firstly, in removal of bacteria from raw water. So, microfiltration curiously often referred to as cross-flow microfiltration, whereas the terms cross-flow microfiltration, ultrafiltration, and cross-flow reverse osmosis are never used. It's a relatively new processing technique in the dairy industry. In the introduction really started with the development of mineral microfiltration membrane made from alumina or from zirconium oxide support on carbon. The total area in the world dairy industry was less than 750 meter square, but studies have projected a potential market 6 to 7 times higher than that for ultrafiltration. In dairying, microfiltration applications have gained increased attention because of the wide range of available pore size, which makes it possible to separate and fractionate all milk particles. Decontamination of raw milk is generally achieved through heat treatment. Various combination of time temperature treatment can be used depending on desired bacterial effect, while heat treatment is necessary to ensure the safety of milk and milk product. It's almost always induce irreversible modification of milk component, alter physiochemical equilibria, and also affect the organoleptic quality and cheesemaking properties. So that's about removal of bacteria from raw milk. Next, about casein enrichment of cheese milk in application of cheese making. Firstly, the selective separation. So, microfiltration of skim milk with 0.1 micrometer pore size membrane enable the selective separation of micellar casein, that is native calcium phosphocaseinate. Depending on the amount of microfiltrate removed, referred to by Mauvios as in ideal way because of its saturatory and its composition. The casein content of the retentor increase. So, consequently, application of microfiltration retented, such as through aforementioned for ultrafiltration retenteds, is in cheesemaking can be done, but prior removal of microfiltrate from the cheese milk offer the cheesemaker a method for optimize both the cheese process and the value of the co-product. Membrane microfiltration membrane of 0.1 micrometer pore size combined with diafiltration with water allows the preparation of new dairy product. So the third one for application of microfiltration in cheesemaking is selective fractionation of globular milk fat. Separation of milk fat into small and large globe was proposed by someone in 2000 using special ceramic microfiltration membrane under hydraulic condition, which caused no damage to the native fat globe membrane. Use a patented process. Cheese made from milk with small globe and had higher yield and smoother and finer texture, probably because of the interaction of fat globe membrane with the cheese casein matrix and the difference in triglyceride content on the fat globe according to their size.
Okay, NAZMI, thank you. Now, I'm going to explain about membrane configuration. In membrane configuration, there are 4 types of configuration. The first one is tubular, the second one is hollow fiber, the third one is plate and frame, and fourth one is spiral wool. Okay, the first one is tubular. The tubular is easy to clean, allow a recirculation of liquid, has the lowest surface area to volume ratio, and it require high feed flow rates, require high running energy, and it has high levels of solids and viscosity. The feed flow tube size is 3 to 25 millimeter inside diameter. Okay, this configuration usually used in microfiltrations to remove bacteria, and they also call this process as bacto catch. Okay, the second one is hollow fiber, where it has a feed flow tube size 0.19 and 1.25 millimeter inside diameter. It requires low surface area and low operation pressure, and it requires low energy consumption, but it's not suitable for high pressure application. It has high surface area to volume ratio, and it able to backflush to prevent any build-up of fouling material on the surface. Okay, this method mostly used in ultrafiltrations and microfiltration application. Okay, the third one is plate and frames. Plate and frames usually consist of stacks of plate and a flat shape of membrane. The surface area to a volume ratio is between the hollow fiber and the tubular design. Okay, this plate and frame has a feed flow parallel to the surface, and permeates is channel out of the module. It's require a pumping energy around 0.5 to 0.7 kilowatts. Okay, the last one is spiral wool. Okay, this configurations is mostly used in a dairy and a food industry. Also, the pack density is around 100. The pack density is around 300 to 1,000 meter square. It is most inexpensive. The plate and frame is wrapped around a center collecting pipe. Okay, it can minimize fouling, and it is difficult to clean and to sanitize, but it is available to throughout all application, whether it's microfiltration, nanofiltration, ultrafiltration, and RO, reverse osmosis. Okay. Okay, now I'm going to explain about advantages of membrane technology. The first one, it is more economical in energy consumption. Then the second one is it can produce a high quality of products. Next one is it can minimize the loss of the nutrient value. It can minimize loss of nutrient value. Fourth one is it can increase shelf life extension of foods, and then it can create green image. Okay, now I'm going to explain about the limitation. Okay, the first one is the process are prone to membrane fouling effect, which is lead to decreasing in permeate flux. Okay, it is expensive to clean, and regeneration schemes are maybe necessary. Okay, next is it has high flow rate used in cross flow fluids can damage shear sensitive material. And third is equipment may cost higher. And then last one is if the membrane manufacturing process is not precisely controlled, membrane with wide pore size distribution may result in giving poor separation performance.
For the conclusion, membrane technology is a must and have been used widely in this world. This involves variety of technique to do process of separation and highly specialized equipment for cheese making industry. Many new cheese varieties might be prepared by combining the properties of mineral adjusters, ultrafiltration retardants, and enzymic abilities of lactic starters. In the future, numerous ideas for cheese scientists and technologies may also originate from microfiltration application. Last but not least, removal of the entire contaminating flora by microfiltration also offers a means to study precisely how much type of starter bacteria added to the cheese milk will act on ripening of different cheese varieties.